for Statistical Consultation at University of Stellenbosch. The Center for Statistical Consultation provides statistical service primarily focused on students and researchers within the university, but also so reaches outside the university. At the center, Prof. Kit has done consultation work in a wide variety of fields spanning biostatistics, social sciences, and more. This is quite a mouthful, Professor. And you've done a research week for us previously as well. And thank you so much for your positiveness and your willingness to share your knowledge again this morning. We will do the questions at the back at the end of the session, but I would like to know whether I can maybe stop you if I see there's a question really related to what you are actually saying at the moment.
Anytime.
Okay, thank you so much. So over to you. We would like you to share your camera that we can see you while you present, if you don't mind.
I think my camera is on at the moment, so you
yes,
should be able to see me. I just need to be able to share my screen now because I think I'm still seeing your screen.
You should be able to share your screen now.
Okay, but I am still seeing your screen being shared. Okay, there we go. Okay, I just want to confirm, are you able to see my presentation?
Yes, thank you, Professor.
Okay, thank you everybody for tuning in to this presentation. I've already been introduced, but just again, my name is Martin Kidd from the Center for Statistical Consultation. And the purpose of this presentation will be just a broad overview of the role of statistics in research and where we as statisticians play a role, and hopefully you will be use this information, you will be able to use this information in your research and understand exactly where and how the statistics play a role and how we can maybe assist you with that. Okay, so just an outline of what I'm going to be talking about. I'll start off by sort of following, let's say, the process of a research project. So it starts off with the planning and then the execution of the project itself, the data capturing, data analysis, and reporting afterwards. So I'm going to spend some time with each of those bullets, and you can feel free to stop me at any stage if something is unclear or if you have a question. Okay, so the first thing that I just want to highlight is different types of data that one can get. And the reason why I want to show that now is because the types of data will influence the kind of statistics that one will do. So this is just prior information so that you can understand when you are collecting data that there are these different types of data that one work with. So the first type is what we call nominal or classification data. It's typically data that is used to identify subgroups in your data set. So as an example, if you have a variable called gender, which can be male or female, then it identifies two different groups. So the main characteristic of this kind of data is that there is no order in the outcome levels of such a type of data. So between males and females, it's not a case of the males coming first and the females coming second. So there's no order in there at all, and that obviously plays a role in how one would statistically analyze such data. Okay, then the second type is now ordinal data, and as the name indicates, the order is now important, but the distinction here is still that it is still discrete outcomes. So typically, if you are counting stuff, then the counts are like discrete outcomes, 1, 2, 3, or 4. If you have, say, a Likert scale response that can either be, say, low, medium, or high, then it has these discrete outcomes, but the order is important. So in a low, medium, or high outcome, the low is comes always first, then the medium, and then the high. And again, one would like to use that information when you do the statistical analysis. And then the last sort of broad category is what we call continuous data. So those are measurements that are done. So if you, say, for instance, would measure the weight of people and want to statistically analyze that for some reason, then those measurements are sort of measured on a continuous scale between a certain minimum and maximum. And obviously it is ordered, but it is not discrete outcomes. So the measurements depend on the measurement instrument that you use as to how accurate the measurements will be. Now, these are very broad categories. If you go and read up in statistical books, you might get further breakdowns, but I tend to just go with these three broad outlines. And typically, for statistical analysis, the ordinal and continuous data would sort of roughly be dealt with in the same manner, depending on the type of ordinal data. Okay, so that is sort of the type of data that you can expect to encounter if you start collecting data. So let's now look at the planning phase of a research project and where the statistics fit in. Now, what's important is that the aims and objectives will determine the statistical content. All statistics that will be done will sort of be driven and directed by what is your objectives and what kind of questions are you asking. And at this stage, if your project will include a statistical aspect, it's already very important to start doing proper statistical planning after you have sorted out your objectives. And we as statisticians, we would like to be involved in this stage already, although it doesn't happen all that often. But I think we can give quite useful input into the planning stages in terms of how the data should be collected and how experiments should be conducted, or if you are doing, say, a survey, how the survey should be conducted, and so on. So typically, questions that will be addressed from a statistical perspective will be, what is your population that you are investigating? It can be, say, just, let's say, the population of the Western Cape, or it can be the population of the whole of South Africa, or whatever the case may be. And that will, in a way, determine and drive how you're going to collect your data, because one would like to, when you collect a sample, you would like that sample to be representative of the population which you are researching. Then there are possible experimental designs that one can consider. I've just indicated sort of two typical experimental designs where if you have, say, some kind of intervention, you will have an experimental group that was subjected to the intervention, and you, say, might have a control group that were not subjected to the intervention, or might decide to measure pre and post before and after the intervention. So there are all these kinds of possibilities and different experimental designs that one can choose from. And there we as statisticians can again play a role in terms of advising what is, let's say, the best possible or the best design for the specific research that you are conducting. Okay, I want to spend a bit of time on questionnaires because we do quite a lot of statistical analysis on questionnaire data, and it can, in some cases, become quite tricky in terms of, let's say, the questionnaire design and so on. So I'm just going to give some guidelines on questionnaire designing if you are conducting a questionnaire survey. So the first thing that one would like to do is to use existing instruments. So based on your objectives, the best thing would always be to go and look in the literature and see if other people have collected data similar to yours and what questionnaire instruments they used. And if possible, then it would be advisable to use those same questionnaires, because usually those questionnaires were already validated and you can then say that you are using a validated instrument. But in many cases, you have sort of a customized objective where there are no, let's say, specific questionnaires available to address the objectives, but then it's still advisable to base the design of your questionnaire on previous studies so that you can see what other people have done and learn from them and set up your questionnaire based on that. What is quite important in the questionnaire design phase is to already start thinking about questionnaire validity at this stage, because there are various different types of validity and reliability that one has to consider, of which content validity is probably the most important one. And that indicates whether you are asking the correct questions to address your objectives. So that is a non-statistical exercise where you will get experts in the field to look at the questionnaire and give advice as to whether the questions that you're asking are appropriate or not. But then there are various statistical reliabilities and so on that might be applicable or might not be applicable, but it is advisable and I think quite important to already get an idea of, in terms of your questionnaire, do one have to calculate reliability? Is things like discriminant validity important or not? Because these things are not always applicable to all questionnaires. And again, that is where we can play a role to indicate to you that this is the kind of reliabilities that you will need to do, and that will then further determine on how exactly you're going to perform your questionnaire survey. And I've just seen that too many people ask these questions after the survey. I've had many instances where people have actually written up their thesis completely, and then an examiner comes back and say you haven't reported anything on reliability, and then one has to start addressing that. And it is advisable to, at the design phase, to already sort of know exactly what you need to do and what is required. Okay, then from a statistical perspective, the type of responses that you have to questions is important, and one sort of need to carefully consider what is the best responses to the questions. So if you have a list of choices, the first thing that one must determine, can the respondent only select one choice? So if you say I have a question that say what is your sex or what is your gender, and then obviously they can only select one of the options available. But in some cases there are questions that that can sort of require multiple selections. So if you say what sources of information have you used, and say you've got 10 different sources there, then they should be able to select more than one source that they've used. So one must make a clear distinction between the two. And also in the wording of the questions, you must indicate clearly whether the person can only select one option or whether the person can select more than one option. For continuous data, you know, if you're asking numbers from people, like age, for instance, if it's, let's say, ethically viable, and if the person can provide an accurate number, then ask the actual number. So, for instance, for age, people tend to always have these age brackets, say from 20 to 30, 30 to 40, 40 to 50, etc. But from a statistical point of view, one would actually like the more accurate actual age. So if it is at all possible, just let them give their age exactly on the questionnaire without providing certain ranges of ages. There are obviously, say, other things like, for instance, income, which could be a fairly sensitive thing, or say a value that they must estimate, and you know they cannot really estimate it very accurately. In those cases, it would then be preferable to use like different brackets, but if possible, let them complete and give the exact numbers, because that is will be the most accurate data to work with. Then one usually have open-ended questions, which is always a good idea, because the advantage of an open-ended question is that you are not forcing the person to stick to certain options to be chosen. So the advantage is that they can use their own words to, say, express opinions or whatever the case might be. But if they are sort of, let's say, specific choices, don't use open-ended questions. So for instance, if you say have a question, what is your marital status? If you make it an open-ended question, then you're going to get all kinds of different responses to that, and that makes the statistical analysis quite difficult, because you have to do a lot of cleaning up on the data. So in cases like that, it is preferred to have a list of options, but typically where open-ended questions will be used is if you want certain opinions on things, and then you can have open-ended questions and say, okay, in your own words, express your opinion on this issue, or whatever the case might be. But just keep in mind that these open-ended questions are time-consuming to analyze, and they are sort of, in most cases, not really statistically analyzed. So it's going to be up to you to read through all the responses and summarize the responses in a way, and that can be time-consuming to analyze, but in many cases still fruitful to do, because you are now getting people to answer in their own words, and that can give better information than say, other questions where you've restricted them to specific options that they should select. Okay, then one have Likert scales, which are commonly used on questionnaires, where you say have a statement that you provide, and the respondent must say to what degree he or she agrees with that statement. So you will typically have, say, a Likert scale that runs from completely disagree to the one end to completely agree on the other end of the scale. And mostly what one has to decide there is, how many options should there be? Should it be like a 4-point, 5-point, 7-point scale? I think that 5-point is probably the most often used. The one distinction that one can make here is whether to have an even number or an odd number of options, because if you have an odd number of options, there will always be a middle one. So let's say you have a 5-point agree scale, then it will be completely disagree, neutral, which is then the middle one, and agree and completely agree. Whereas on the other hand, if you have an even number, so a 4-point scale will not have the neutral in between. It will only be completely disagree, agree, completely agree. So if you want the people to commit themselves to either one or the other side, then you should use an even number. But if you say, no, look, there can be people that are completely neutral in the middle, then you can use an odd number of options. Be careful of the wording of these options, that they fit in with the question that you are asking, and also be sure that the question you are asking can actually be answered on a rating. Sometimes you can ask a question, I'm just going to use like a stupid example. For instance, do you have a car? And you cannot answer that on a Likert scale, because it can only be a yes-no response, whether you have a car or don't have a car. So be careful with that kind of thing. Note that on a questionnaire, you don't have to have the same Likert scale responses across all questions. It is entirely linked to the specific question and how the question is phrased. So if you have like a statement, then it can be from completely disagree to completely agree, but you can say, have another question that you say, how many times do these events occur? Then you can have things like, say, once a year, once a month, once a week, once a day, or whatever the case may be. So the wording must tie in with the content of the question. And also make sure that your wording is ordinal, because I see that quite often, in that when you look at the wording, you're not quite sure, does this option now have to be to the left or to the right of the previous option. Here's an example where you can see the Likert scale runs from completely disagree to completely agree, but right in the middle there's an answer that says unsure. And if you think carefully what unsure means, it then means that maybe that person does not have enough information about the question that you're asking to actually give an answer. So you would then mark unsure, but then it doesn't fit in with the scale on the level of agreement. So what would be, say, a better one is to use the word neutral there, because that sort of fits in between the disagree and the agree options. Okay, so that is sort of in short just some guidelines on questionnaire designs. Again, we can also assist with the questionnaire designs and look at questionnaires and give comments on the questionnaires based on the statistical aspects of it. and what we think will work and what might be issues. And then I'd like to say a few words about sample sizes, because that is a question that I always get, especially now in the planning phases, and especially when you have a protocol that you need to be, say, ethically approved or whatever the case might be. Then the issue of sample sizes always arises. Now, firstly, in 99% of cases, the sample sizes are actually governed by time and money. So that's sort of the first question that I will ask you, is how much time and how much money do you have? Because from a statistical point of view, the larger the sample size is, the better results you're going to get. So usually within your practical constraints, you should try and collect as much data as you can. But especially for ethical approvals and so on, they in many cases require that the sample size calculation be done. And what you must understand here is that to do sample size calculation is not a trivial exercise, because one needs sort of prior information to base the sample size calculation on, and that is in many cases hard to come by, or in some cases that kind of information doesn't even exist. And also sample size calculations are based on specific statistical techniques, so one needs to have an understanding of what kind of statistics will be required before you can do the sample size calculations.
Professor,
yes.
There's a question. I have seen a study in which a Likert scale was used. The scale was agree, neutral, disagree. The researcher then calculated and interpreted the mean value and standard deviation. Can this be done?
The short answer is yes, it can be done. The longer answer is this is now just a 3-point Likert scale. So maybe the means and standard deviations is not quite appropriate. So I would, in a 3-point Likert scale, I would certainly try different ways of analyzing the data. But the short answer is yes, it can be done. And I have indicated in the second slide where I've talked about the different types of data that I usually treat ordinal and continuous data in the same manner. Now, this will be a good example of an ordinal type data, and so one can do that. But I also will note that there will be people that will question that, say, but is it viable to do? But from a statistical perspective, the conclusions you're going to make from that by calculating means and standard deviations will probably be almost the same as if you've used other statistical methods. Okay, does that answer the question?
Thank you, Professor. I think so. Thank you.
Okay, so to carry on with the sample sizes, just to give you an idea of the process that is sort of followed and the kind of information that is needed. So to be able to calculate the sample size, one need to know effect sizes, and also you need to know what the power is. And I'm not going to go into any detail sort of exactly what let's say power is, because power is sort of the least of the problems, because one usually sort of use an 80% power, and that has become like an acceptable norm to base sample size calculations on. So that one is fine. The effect size is more complicated. And just to explain what is meant by effect size, and I'm going to explain it at the end of an example. Let's say you've got two groups that you want to compare. Let's say a control group and an experimental group, and you've measured some measurement, like say weight or whatever the case may be. And the idea would now be to see if there's a difference in the mean weight between the two groups. Then the difference in those means between the two groups, sort of relative to the variation in the data, that is what we mean by effect size. So essentially, the role that effect size plays on sample sizes is that the larger the effect size, meaning the bigger difference between the groups, the less data you need, and the smaller sample sizes you need to show that the differences are actually statistically significant. Whereas if the differences become sort of a bit subtle, but there are still differences, then you're going to need larger sample sizes for the smaller effect size to indicate that the differences are still statistically significant. So that is now sort of, let's say, the big problem with the sample size calculation is what effect sizes do you base your sample size calculation on? And this kind of information is usually not known because it almost becomes like a chicken egg situation here, is that you actually already need to know what your results are to be able to do a sample size calculation. So what one would usually do is to either look in the literature to see if other people have measured the same things that you are measuring, and what means and standard deviations do they report. So one can use that as a baseline for determining what effect sizes we're going to work on. Or you can, which is probably the best option, and if it's possible, to do a pilot study and collect some data before you go on to a main study. And then one can use the pilot study results to calculate sample sizes. So that's sort of the ideal way to deal with sample size calculations. But probably 90% of projects you are not in a position to do like a proper pilot study. So then one tried to use prior data, or if there are no prior data available, then one sort of just select an effect size sort of here in the middle, like a medium effect size, and base a sample size calculations on that. But this is just to maybe to highlight that sample size calculations are not easy to do. So allow enough time, let's say, before your due dates, so that one can properly look at the sample size calculations. Okay, then in the execution phase of the project, one would like to do like pilot studies before you start your main study. So if you are sort of working, say, in a laboratory, and you've got certain laboratory experiments that you need to do, then it is sort of essential that you do some pilot stuff beforehand, so that you can make sure that your laboratory procedures are sorted out and that you understand exactly what you have to do, because you don't want to encounter those issues when you do your main study. And typically, say for a questionnaire survey, I always advise people to just do like a very small pilot study, say where you just get 3 or 4 people to complete the questionnaire, and then ask them whether they had any issues with the completion of the questionnaire, or were there questions that were difficult to understand. How long did they take to complete the questionnaire? Because those are all useful information for maybe adapting the questionnaire, or once you send out invitations for the main study, then you can indicate how long it will take to complete the questionnaire. There are cases in a questionnaire survey where you need to do like proper statistics on the pilot data to be able to adapt your questionnaire. And then the pilot study becomes an integral part of the whole project. And then you obviously need to do a properly sized pilot study to be able to do statistics on that. So those are all things that need to be sorted out in the planning stage already. Okay, at this stage, it's important to sort out procedures for data capturing. The statistician can and should give advice at this stage because data capturing is an extremely important sort of step in this whole process. And one can then, at this stage, now just going back to the pilot study, possibly do interim statistics to calculate more accurate sample size calculations, as I've said before. Okay, I'm going to spend some time on data capturing because that's quite important. It's very important to make sure that your data capturing is done correctly because unfortunately you need to follow like strict guidelines because when one do statistics you need the data to be in a specific format. Sort of the broad outline is that you need to have, say, all your cases in rows and variables in columns. And I'll go into that in more detail just now. But just to give you an idea of how important this data capturing step is that I spend 90% of my time cleaning up data and 10% on the statistical analysis. And if the data is captured in an appropriate manner, then it obviously cuts down on the cleaning time of the data, and then it makes sort of my work much more efficient. So this is very important, and also obviously the accuracy of the data capturing is important because if the data is captured inaccurately, you're going to get inaccurate results. Okay, so some further guidelines. If you have to type in your own data, then it's commonly done in Excel. And the problem is now that in Excel, you start off with a completely blank sheet. And there are many ways of organizing the data. And I've encountered many wonderful ways in how people organize their data on an Excel sheet. But most of these ways that they do that is not compatible with the way that we needed to actually do the statistical analysis. So essentially, variables that are measured, so let's say variables like demographic variables or variables that indicate measurements, they go in columns. And your subjects or your cases of your sample, they go in the rows. So that's very important. Then each variable or each column must have a unique name, and I'm going to say a bit more about the names just now. And what's important now is that the names go in the first row in the Excel sheet. Because if one now imports the data into the statistics package from the Excel sheet, then the statistics package takes the first row as the names of the variables, and it starts importing data from the second row onwards. So what happens frequently is that people have Excel sheets where they use like the first 3 or 4 rows to identify the columns. And then one has to sort of panel-beat the data to give sort of proper names that occur just in the first row, and then you have to delete all the other rows so that your first data point starts in row 2. So that is quite important. Have data for different groupings, say for a control and experimental group. then the data must all be on the same sheet. And I encounter that also quite often, is that I get an Excel file with, say, 3 different sheets, and they've got 3 groups that they want to compare, and the data for each group was given in a separate sheet. But eventually, when we want to do the statistics, obviously the data must be all together. So now I have to go and merge the 3 data sheets into one. So it will be sort of more advantageous if one can sort of capture the data all in one sheet, if possible. There are some cases where you cannot do that, but mostly one would require the data to be all on one sheet. Give nice descriptive names for the variables. The statistics packages nowadays can deal with sort of nice descriptive names. In the old days, they couldn't deal with, I think, more than 8 characters. That's not a restriction anymore. So you can use even like terms with more than 1 word as a name for a variable. Just try and stay clear from long sentences, because then the names just become too long. But when you give names to the variables, just keep in mind that when the statistics is done, these names will appear, say, on graphs that is produced, and you can already sort of anticipate what your graphs will look like and what the names will be. And if you now give proper names, then one don't have to edit the graph and edit the labels on the graphs. Also, for nominal variables, you can actually give the actual names of the outcomes for a nominal variable. So again, if we have gender, which can be male or female, you can actually type in male, female in the data. So there is sort of a slight misconception that we always need numbers. So people, in many cases, would give me a data set with, say, if there's a gender column, then they've coded the male, say, as a 1 and the female as a 2. The problem then is I need a key to understand what the numbers actually mean. Whereas if the text is already in the data set, then I will know exactly what it is. And I can also in that way distinguish between, say, ordinal responses and categorical responses, because if I see, say, numbers 1, 2, and 3, then it can indicate, say, different race groups, or it can indicate the ordinal scale from, say, low, medium, and high. And but when I see the numbers 1, 2, 3, I'm not quite sure how to deal with it, and then you'll have to provide that information for me. So it's preferable for me to have the actual text in there. If you have ordinal variables, then it can in some cases be more advantageous to put numbers in there. But also, I'm quite happy to work with the text, because I can fairly easily in the statistics package just assign the correct numbers to an ordinal variable so that the order is preserved. Like in that example where I would indicate 1 for bad, 2 for medium, and 3 for good. Okay, just some last points. I specifically do have a system where I can actually customize an Excel spreadsheet for a specific project and a specific set of data to be captured, which will make the data entry easier and will also ensure that the data is captured in the correct format, and which will make the cleaning up much less. So you can ask me if it is applicable to set up an Excel spreadsheet for you. But just note that we don't do any data capturing ourselves. So the data capturing part is all your responsibility. And it is probably the most important step in the process, because one can sort of very easily get lost in a sea of data. And if there are mistakes in the data, which there in many cases are, the analysis unfortunately has to be rerun. The statistical packages are not that sophisticated yet, so that one can just make a change to the data and all the statistical analysis get updated. So it has to be rerun. So one have to, in this data capturing phase, try and restrict the mistakes to a minimum if possible. Okay, so once the data has been captured, then we now get to the data analysis part. And this is mostly dealt with a statistician. So we can actually do the statistical analysis for you, depending on what your requirements are. I will always start with just doing summary statistics, like frequency tables, mean, standard deviations, etc. And this is for me always an important first step to identify issues in the data and understand sort of what the distribution of the data is. And here's an example. Let's say this is an effectiveness variable that were actually measured on a 5-point scale. And now I have gone and made a histogram of the data, and I see that there is one case that is was entered as 11. And this is then quite clear that it must have been a typing error or whatever the case might be, so that need to be updated. And many times I will send back these histograms and say to you, just check the histograms to make sure if there are not values that you can immediately see is a problem, and then one can rectify that before we start doing the actual analyses. Okay, just some more examples of summary statistics. We sometimes use these so-called box plots, which is a nice compact way of showing the distribution of the data. So those small square markers that indicates the median of the data, and the big boxes indicate where 50% of the responses lie, and the tails then indicate where the other 50% of the responses lie. And one can see this can be a very useful way of comparing, say, different groups with one another. So there are sort of various different options of displaying summary statistics for a data set. Okay, so once we've done the summary stats, then this is sort of as far as I can go as the statistician without any, let's say, prior information as to what the objectives, etc. are. So I can do the summary statistics, but after that, we must be guided by the researcher on what further analysis need to be done. So you typically formulate a list of questions based on your objectives, and from these questions, then the statistical hypotheses are derived, and that is sort of, again, where we play an important role, is to, based on the questions that you're asking, indicating what the hypotheses are and what statistical methods are most appropriate. But the one thing that is very important in this guidance to the statistician is that you must remember that we as statisticians are not experts in your field. So we don't understand the jargon of, let's say, your research domain. So be careful that when you give your information as to what comparisons need to be made, try and give that information based on the variable names that are given in the data, because sometimes people use terms that are unknown to me, and then I have to go and now look in the data and see which variable is this person referring to. And in many cases, I don't know that. But if you sort of cite the actual variable names as they occur in the data, then I will know exactly which variables I'm talking about when you start giving instructions. Okay, so the specific statistical analyses and techniques that we used are determined by the questions that you are asking, and not the other way around. Because in many cases I get a phone call and people will say, okay, I want to do a regression analysis. Can you assist me? Then the first thing I would ask the person is, okay, please just explain to me what your objectives are. And in many cases, I've actually then after that, after I understood what the objectives are, I have sort of said that there are other more appropriate ways of actually statistically analyzing the data. So we as statisticians play an important role there in advising as to which is the best statistical methods to use. Okay, appropriate techniques are dependent on hypotheses and types of data. This is where the types of data that I spoke about earlier on starts playing a role. So here is some examples. So if you are comparing means between groups, you will typically do an analysis of variance. Or if you are comparing categorical variables, then you will typically do a cross-tabulation with the chi-square test. Those are the two statistical methods that I probably do the most in the consultation work that I do. But there are obviously many more different ways of analyzing the data, and that is what makes it sometimes a bit problematic in the sense that one needs to understand the objectives and then understand which statistical methods are the most appropriate to use. Just as an example, here is the kind of output that I will provide, say, for an analysis of variance. So you can see here we've got two different company types, say declining or stable or increasing company types, and there's a variable called business practice application that was measured, and the circle markers then indicate where the mean scores are, and then at the top of the graph are given some statistics, which I'm not going to go into any details now, except to say that we will guide you in terms of how to interpret results once we have provided a statistical analysis for you. Just a word on statistics packages. At the center, we mostly use Statistical, and the university has a site license for Statistical. So as a registered student, you can actually install Statistical on your computer. The only drawback there is that it's only available for Windows computers, so you cannot use it on a Mac. Then the university also have site licenses for SPSS and SAS. SPSS is the one that is commonly used in the social sciences, and I think for SPSS you do have versions available for the Mac as well. SAS is probably in the statistical community the most well-known one, but it's a very big package. It's extremely expensive. But we also do have that available at Stellenbosch University. Then there's a package called R, which is a free package, freeware as we call it. So you don't have to pay anything for it, and it is completely comprehensive. So basically any kind of statistics that you will do, you will find like what we call a package in R that can do that. But although there are like front ends like R Commander and things like that, in general R is a fairly difficult package to use. But in the center we use Statistical and R in combination, and I use at this stage R for most of my statistical calculations. Then we have various other specialized packages like Design Expert, which is a package just for experimental designs and so on, but they're more specialized and there are no like site licenses for them. So if there is a requirement, then you should come to us. Okay, then the last thing that I want to address is the reporting of results. Now, the reporting of the results and the write-up of the results is the responsibility of the researcher. So if you're going to ask me, can I just write a short page on what the final results are. I'm going to decline that and say that's your responsibility. Unfortunately, we cannot go any further. That is the responsibility of the student to do that. But as I've indicated earlier on, we will definitely assist and guide with the interpretation of the results. So if I have done statistics and sent the statistics to the student, then I will, in 90% of the cases, book a follow-up appointment where we sit together and we go through the results and I explain how to interpret it. And my office door is always open after that, if you are still uncertain about things, to come and clear it out with me, because it's obviously extremely important that you understand the statistics and understand it correctly so that you will be able to write it up correctly. The actual writing, as I've said, that should be done by the researcher, but we can also read through the results sections of your say thesis or paper and make comments on what you've written and indicate if there are maybe, say, incorrect conclusions or maybe cases where you can just state the results slightly differently so that it is more clear. So we can do that. Then there's the matter of co-authorship. The question always is, should the statistician be the co-author? And we've sort of had many debates about that in the past, and we have left it up to the principal researcher. So that decision is entirely up to the principal researcher, and we will be happy either way. There are some cases where I've only done a t-test and I was put on as a co-author, and there are other cases where I've done a lot of statistics and my name wasn't even mentioned in the paper. But our objective in the center is to get these papers published, and we will do our best to sort of deal with the statistical issues, regardless of whether we're a co-author or not a co-author. If you decide to make me a co-author, then I would like to have insight into the paper before it is submitted. So typically I would read through the results section and make suggestions there if necessary. Okay, so to end off, just some further information about the center itself. So our primary aim is to assist students and researchers with statistics. We are currently 2 people in the center. It's myself and Professor Darnell, and we are non-academic personnel, so we don't do any teaching. We only do statistical consulting, so that is what we are here for. Just a few words on funding. The center is funded roughly 50%, maybe slightly more centrally by the university. So unfortunately, the rest of the money we have to get in via consultation fees. And the tariff for this current financial year for 2022 is 360 Rand an hour. So it's a very reasonable rate that we are asking. But the main thing here is that this tariff is to be paid by either the department or the study leader. So the payment is made via an internal requisition transfer, and so the money has to be made available either by the department or the study leader. So if you want to make use of our services, just run it by a study leader to make sure that it is fine, because the study leader is going to be responsible for the payments.
Professor,
yes.
does the Statistical Center do online sessions for students outside South Africa?
I will get to that just now. You mean Stellenbosch students outside South Africa?
The question was outside South Africa.
But is it still people that are registered as students in Stellenbosch?
I assume so, yes.
Yes, it doesn't matter where you sit. Now with the technology that we have available, one can set up, say, a Teams or Zoom meeting, and I can assist anybody at any part of the world, given that you do have internet access where you are. Okay, so there are two faculties that actually do make funds available, where the dean makes a fund available. So people from economic and management sciences, they actually get the service for free because the dean makes a fund available. So we just send the account to the dean to pay. And also at education, currently students from the education faculty can come and see us without having to have the study leader pay for the services, because there's also the dean also are prepared to cover our cost. But just understand that we do not invoice students personally. So if your study leader does not want to pay, then the study leader will have to still make the funds available, and then you must just pay the study leader. So we are not unfortunately not in a position to invoice students personally, because the invoice procedure is quite a sort of a long winding procedure. Okay, that's the end of my presentation. Thank you for listening, and I will try and answer any questions if there are questions at this stage.
Professor, I cannot see any questions anymore. Is there somebody else? There's a lot of hand claps. And there's thank you so much for arranging this webinar, and thanking for a very interesting presentation, and a lot of hand claps for Professor.
Okay.
So thank you for allowing me to interrupt you during your
Thank
session
you,
for
thank
questions.
you, thank you.
I don't see anything. May we suggest external people to contact you too?
Yes, we do also provide services to students that are not registered student at Stellenbosch University, but we deal with them in a completely different manner. So for them, we have to charge a proper consultation fee, but we do that. There is quite a few students from other universities that I actually do assist. So that is possible, but our main focus is for students and researchers within Stellenbosch University.
I see there's a hand up. Can you just put on your microphone and ask a question?
Yes, thank you for the session.
Oh, gosh.
My question is, when you use a Likert scale, I think I've seen one or two papers where they kind of summed up the scores, but are you just supposed to interpret your data in terms of this proportion of people agreed and this proportion of people were neutral? Is that okay to analyze your data or interpret your data?
Yes, there are various different ways of doing that. The sort of, let's say, more cumbersome and roundabout way would be to express it as percentages for each option of the Likert scale. But essentially, then you are not making use of the ordinal nature of the Likert scale. So I sort of prefer to analyze the Likert scale data by actually calculating means, because one then just assign numbers, say from 1 to 5 for the different Likert scale options, and then you can calculate the mean, which will lie between 1 and 5, where if the mean is 1, it indicates that the majority of the respondents did not agree, and if the mean goes closer to 5, then it would indicate that most of the respondents tended to agree with the statement. So that, for me specifically, is the better way to do it. But it depends on, let's say, firstly the objectives and also what your preferences are. In some cases, people say, no, but we would like to report percentages for each option. Then I will happily provide that.
Thank you.
Any other questions? Okay, with that, then thank you so much for your presentation, Professor Kidd. It was well received, and the people are happy. And thank you for being always willing to assist with our research week.
Okay,
And
I'm happy to be of any assistance, and thank you for giving me the opportunity to do this presentation.
there's such an important issue in doing research, so we have to have you. There's a lot of thank yous, and with this, Professor, will you please just send your PowerPoint to Lucinda that communicated with you, that we can upload it, and the recording will be also uploaded within a week or two. And
Okay.
thank you so much, and I hope that some of the students will contact you.
Okay, that's fine. Thank you.
Definitely.
Thank you very
I
much.
sent an
And
email
with
already.
this, the session is finished.
Okay.
Thank you.
That's right. Bye-bye.
Bye-bye.
Bye.